Hello everyone, welcome to my latest video, Back to Watch Me Do Math. We're going to be talking about different resources that will help you increase the ability to problem solve in terms of maths and physics questions. So the reason I'm making this video is because there are a large variety of resources out there, and to be honest, most of them are pretty good. I'm going to be going over ones which are free and ones which I have used myself, or I know people have used them in the past. And this is based off either my or other people's personal opinions and perceptions of their difficulty. Because in this video I'm going to be going from the easiest resources at around IGCSE level up to the hardest pre-university resources to prepare for solving maths and physics, perhaps in your interviews or in your aptitude tests or other admissions tests that you need to get into university. So let us begin. The first category, as I did say, was IGCSE papers. And the reason that I wanted to include this is because it sets a baseline of difficulty, and by and large anything else can be compared to it, given that it's the sort of standard from which everyone starts the last 2 years of secondary school. So first you have your IGCSE papers. There are Cambridge, there's a CAIE, which is the Cambridge Assessment and International Examination, and the CAIE IGCSE physics papers are the hardest out of the exam boards that I have seen, I think. Followed by Edexcel and the other exam boards, which I do not have experience with, and I cannot make an assessment of their difficulty based on that. But this is what I know about the IGCSE papers. Secondly, I would also point you to the IGCSE Further Pure Maths exam. This is a mathematical paper, purely mathematical paper, not a physics paper. But it's pretty good for problem solving practice, and it is also a sort of baseline for what I'd consider to be when you're really getting into harder maths after year 10 and year 11. So IGCSE Further Pure Maths past papers are also a good resource for problem solving in a quick manner. So I know that Edexcel is what I personally did and what is currently done at my school, but again, the Cambridge admissions, the CAIE additional maths, or add maths as it is sometimes called, is a harder qualification than the Edexcel Further Pure Maths in terms of the amount of content included, because it includes aspects of mathematics like probability and relative velocity that are not included in the Edexcel board's version. So anyway, after these two, there are some other resources that we can look at. These papers, these IGCSE papers, are ones that if I am using any kind of exam past paper to practice, whether it is IGCSE, A-level, I don't practice with IGCSE, by the way. Most of my practice at the moment personally has been about the Oxbridge admissions tests. You have IGCSE, A-level, and more of these kinds of exams can be found at physicsandmathstutor.com. And this website is pretty famous amongst people who, at least people who are in my school, and it is very full-featured, and it is a very fast way to access various past papers that you may or may not need to use. So, for instance, there are some university admissions exams. There are the IGCSE papers. So there's physics here, and you can see at the GCSE or IGCSE category there's a IGCSE Maths, but consider that these are all regular maths. These are not further maths, and if you want further pure mathematics papers, you may need to look them up yourself. For instance, skills in finding exam papers, you would search CIE, IGCSE, additional maths add maths papers. And this way of keyword searching is a good way to find your desired resources as fast as possible. So Papa Cambridge is a website I'm familiar with. I'm not sure on how much of a legal basis this website operates. And of course on this channel I do not condone illegal activity, but this website, Papa Cambridge, has a large variety of Cambridge papers published to their page. So if it goes as far back as 2002, you can have a look at some of them. And they're all downloadable here. So these additional maths papers are harder than the Edexcel for the pure IGCSE papers, and are also a good baseline for mathematical skills. So next we have A-level papers, and again I'm not sure of the comparison between boards here, but there are physics papers. A-level maths papers is an interesting system because, as you can see, there are just so many, it's ridiculous. These are all centered around the fact that there are different modules. There are, I think, there are 18 modules that make up an A-level maths course, and you can see they all have these acronyms here. What they stand for is Core 1, Core 2, Core 4, Decision 1, Decision 2. Well, so Core is basically your IGCSE for the pure maths content with a little bit sprinkled on top. Decision papers, D1 and D2, these are all about questions like, you have two variables, can you optimize this function, which is an output of the two variables, and it's just about comparing two things in a mathematical way. So in this sense, D1 and D2 are probably the next easiest after C1, C2, C3, and C4. And then you have mechanics papers, mechanics 1 through 5. By the way, the numbers go in ascending order of difficulty. So these mechanics papers are basically physics papers disguised as math papers. The maths involved in mechanics papers is all applied to real-life physical situations. So that's what these 5 papers represent. And finally, you've got statistics papers, S1 through 4, and further pure maths papers, which are the hardest of the whole 18 groups. And this ranges in difficulty from 1 to 3. So how does this system work? Well, prior to a reform of the A-level maths system by the UK government, I think it was, A-level maths candidates would have to choose 6 of these, and if you were chickening out and you were not really wanting to do anything mathematical after school, you would take these 6 because they're the easiest. And then if you wanted an additional A-level on top of that, you would have to take 12 exams to get a further maths A-level. And finally, if you wanted 3 A-levels to do with maths, this was incredibly rare as there's no real reason to take all 18 modules unless you're absolutely tryharding and it's your 5th A-level. If you wanted 3 A-levels, you take every single module, and in this sense, you would have completed 3 A-levels worth of content just for mathematics. And this covers basically everything you could possibly expect a Year 13 student to know. So A-levels are an incredibly rich resource for the practicing of mathematics. And if you're particularly interested in the application of that to physics, look at mechanics 1 through 5. Oh, and Cambridge has their own system, which is only split into 11 modules, and I'm not particularly sure how that works. So second, we've got the third, we've got the A-level exams. What next? I'm just going to note down this website, physicsandmathstutor.com, so that you can refer to it later. What next? Okay, so now we go away from the traditional exam format and we look at some other exams that are not necessarily qualifications you're forced to do in school, but are still useful for practicing maths and physics. So if we look at this, uni admissions, there are several of these papers that are relevant to your course. The physics aptitude test is by Oxford University, and it covers it is a good paper if you get confused, because the papers try to confuse you rather than do anything about time pressure or just difficulty of calculation. The calculation is usually quite kind, but these papers just try to confuse you as much as possible so that they can really get to the bottom of whether you have a solid understanding of a physical concept or not. The engineering admissions assessment, by comparison, is good if you have issues with time pressure. These are highly fast-paced papers, similar to the BMAT, but with harder maths and physics, and focused only on maths and physics in equal weighting. There are not many papers, but it's still a useful resource. And there are also some engineering-specific questions that you may want to skip, because it requires you to study outside of the physics syllabus you might teach or you might learn at school if you're just using it as a practice and not preparing for Cambridge engineering. Then there's the sixth term examination paper, or STEP, which is an exam taken after you graduate year 13. It's been going on for many years, as you can see here. All of these papers are focused on providing an incredibly rigorous and challenging mathematical exam, not a physics exam, a maths exam, for people who want to work particularly on maths. Well, there is this section B, mechanics, but I'm not too sure if physics has such a big role in these STEP papers today. So anyway, this STEP exam seems to be independent of other forms of examination at the end of year 13 because it's simply been going on for so long without a change. Finally, we have the Natural Sciences Admissions Assessment, which is a possible resource, but I will not be covering as there are very few papers available and I'm not familiar with the quality of the questions, although I expect they are quite good because this is the Cambridge equivalent to the Physics Aptitude Test and the Mathematics Aptitude Test. And speaking of the MAT, this is a specifically mathematical paper that is meant to be similar in difficulty to the Physics Aptitude Test, but the maths just continues ramping up after halfway through. Alright, so that's it for Oxbridge resources, Oxbridge exams, university exams. Also available on physicsandmathtutor.com. So what next? There are more resources than just this. One that I actually really like is isaacphysics.com. Isaac, as in Isaac Newton. isaacphysics.org is a website that's been run for a few years now by some charitable people. I think it's like a banker bro who graduated from Oxford Master of Physics at some point in the past and has made this website to teach IGCSE and A-level students. And the resources here range from year 10 to year 13 in difficulty. So you can see there's GCSE resources, not going to cover them. A-level resources. Here's where the interesting stuff is. So see this physical chemistry mastery, that's actually about A-level chemistry, and it's a useful practice as well. Solving physics problems is very good because it's particularly about situations in which you are faced with a physics problem and don't even know where to begin. So what else? There's the question finder, which is like an enormous database of physics questions that you can do sorted by difficulty level, ranging from beginning of year 12 to post the end of year 13. There's Master Mathematics, which is a similar database but for math questions. This Physics Skills Mastery is I'm not sure what particularly it is. Oh yeah, it's basically a full-featured A2 or A-level physics syllabus with questions inside. If you want to order these books in print, it's one UK pound, that's 10 Hong Kong dollars, or about 1.2 US dollars plus shipping, so worth it. These books are not made for profit. And this pre-university mathematics for sciences is a bit outdated compared to the rest of the website, so I wouldn't recommend going particularly for this book because other mathematics resources are a bit better. And finally, Questions by Lessons is a decent resource, but I haven't had any particular success with this either. Additional resources, well, Solving Physics Problems, as I already said, is quite good. Extraordinary Problems, I haven't used this resource before, so I won't comment on it. Quantum Mechanics Primer, oh, I've looked at this book before, but it's essentially, it's the same business model as the other books, I'm pretty sure. You can buy the book here, cost price £1, etc. There are 4 chapters in the book, and they're all basically about preparing you to bridge the gap between Year 13 and university physics. So if you want harder physics questions than are available at Year 13, go to this book. And what next is on the list? Right, I want to study engineering. Do I? No, I personally want to study physics, but this is still a very relevant site. So I want to study engineering.com. Oh, it didn't work. I-want-to-study-engineering.org. This website. So, it would say is a pretty good website. It does not have the same volume of problems as other websites, but 200 questions is still a lot. It's nothing to sniff at. So, there is a question index from A-level papers, or well, adapted from OCR exam papers, and there is this problem index which goes beyond the level of A-level problems. So it's all sorted into these categories, and if you are someone who allows cookies, you can actually see which of the questions you've completed over time, and your progress will increase as these numbers go from 0 to the maximum denoted over here. So I want to study engineering, pretty high quality website. I would recommend it, especially if you are wanting to study engineering. That's literally what it's for. So good maths and physics resource. Now what next? I would say a note about IB diploma past papers. However, even though IB maths and physics are notoriously hard, they are also notoriously hard to find because the IB likes money, unfortunately. So despite the quote-unquote non-profit status, these papers are very difficult to find. There is a website called freeexampapers.com that is not operating legally, and so I don't really know what to say about this, but you can find many papers that you wouldn't otherwise find on this website. Well, I think it may be operating legally, but I'm not sure. I don't have anything that definitely says it is not operating legally, as to the best of my knowledge at this time. So yeah, I haven't actually looked into it that much, but people I know have used it before and have not had a negative experience with it. So what else? Right, art of problem solving. By the way, there are some websites in this video are going to be more questionable than others, both from a quality standpoint as well as a legal standpoint. From the legal standpoint, the spectrum is much wider because I'm not filtering for that. But from the quality standpoint, I can assure you that the quality of the questions available on the websites that I show you are going to be quite good because these are websites that I've used before, personally. So, you go to aops.com, AOPS, Art of Problem Solving, and you go to, it's not online school, I always have difficulty finding this menu, but you go to Community, and then you, under the Community tab, you click on Contests. And this basically sends you to a massive tens of thousands of mathematics questions database from national mathematics Olympiads from all over the world. And this is where we start getting into the big leagues of maths and physics problem solving, because this is when you start looking at the questions that entire countries use to select the best from within them. So for instance, to work on mathematical Olympiad questions, I would recommend you start with smaller countries. So, for instance, former USSR countries are actually quite strong at mathematics. So I don't click on one just because you think, oh, I've never heard of this country before and it sounds vaguely Russian, so they must be poor and not good at maths. The USSR was very poor and very good at maths, so it's not. There's no correlation. Or, well, not in general, they just were very good at making a few people extremely good at maths. So like this, Nepal National Olympiad. Interesting. Yeah, there is a high chance this problem was copied. Anyway, this folder format is you would go to this folder full of all the questions from the thing, and you see this button here, View Topic. Say you have this problem that you want to look at. You have this Olympiad level problem. You want to look at it further, you click on View Topic, and it takes you to this forum-like website where people post solutions and discuss questions. So again, this is a pretty epic, pretty awesome maths website. An especially good selection of questions that are below Olympiad level would be from the American Mathematics Challenges, if I can actually find them, USA contests. AIME, this is the highest level, American Invitational Maths Exam. These problems are harder than Oxbridge exams. So if we put a line here and say this is sort of our standard of difficulty, that this is the highest universities will or may ask you to go, getting 90, 80, 90, close to 100% on these exams are the highest universities will expect from you if you are gunning for the very top universities. But there is practice for year 13 and below students beyond this level, and that comes in the form of Olympiads, which I talk about here. If you haven't heard of these before, these are national competitions, like I said earlier, that countries will set up to select teams for the International Mathematics Olympiad and International Physics Olympiad, both of which are very prestigious competitions for pre-university students to prove their physics power, basically, or maths power in this case. So the AMC 8, 10, and 12 are sorted by grade level, so grade 8 would be year 9, grade 10 is year 11, and grade 12 is year 13, the final year of secondary school. And these questions go back to the 1950s. It's absolutely crazy. Or rather, these do not. But yeah, the AMC 12 goes back to 1950. There are tons of questions on this website, including these 3 competitions, which lead into the AIME, and the AIME leads into the where is it? It's called the USAJMO, United States Junior Maths Olympiad, which is the one before the International Maths Olympiad. But anyways, AIME is a level of mathematics above the Oxbridge exams or university exams. Alright, so let's continue. After looking at these Olympiads, there are a few other Olympiads that we're finally going to look at as sort of the highest level of mathematical competition. The first of which is the British Math Olympiad. So if you go to ukmt.org, this British Mathematical Olympiad, it is a pretty prestigious competition, and it's sort of the gold standard for maths competitions before the International Maths Olympiad. You can read more about the selection process here, but I am fairly sure there is a PDF of all the questions here. Well, anyway, somewhere on this website, the UKMT website, if you search BMO UKMT, you will find those British Mathematical Olympiad 1 questions. It's a level of abstract math that I think you would not be expected to go to in a physics qualification, but you may be expected to go to in a mathematics qualification. Okay, anyway, so there's this, and this leads into the IMO, or the International Mathematics Olympiad, and this is like the summit of year 12 and 13 mathematics. So there are, again, tons of past papers, because this competition has been going on for many years. It's been going on for so long that there are some years, I think, like the Soviet Union is still one of the highest scoring countries. But anyway, let's stop here as far as mathematical problems are concerned. So you've got this website, and then also on the physics side of things, you have the British Physics Olympiad, the BPhO. This has several tiers of papers. So if you look at past papers here, you'll see there are many questions available. The BAAO, the British Astrophysics and Astronomy Olympiad, and the BPhO, the British Physics Olympiad, are two papers that are above the level of the Oxbridge and Cambridge, the Oxbridge admissions exams. They're Olympiad level questions, don't get me wrong, and they are, if you can do them consistently, then you are very well prepared for university. Let's just say that. You have this round 1 and round 2 format in both the BPhO and the BMO. That refers to two rounds. Round 2 selects 100 people from round 1, so only 100 people in the whole wide world are expected to take this exam. And anyways, both of them are good fun, both of them are very difficult and challenging, and will be sure to increase your level of problem-solving ability if you can figure them out. There are other challenges here, the year 11, 12, and 13 challenges, and these are like A-level, AS level, and GCSE level papers on steroids, pushing you to the very limits of what you could be expected to know as year 11 in school, in physics. So, this website, again, pretty good. If you are interested in taking this exam, I recommend you push your teacher to sign up for you, because this this competition, or at least for this year, the entry is still open. And finally, we have the International Physics Olympiad, and this is, again, this is the, oh good lord, there are so many. External links, official website. Okay, thank goodness. There's the International Physics Olympiad, which does not have a very professional looking website. You can look at the past papers here. Yep, it goes back to 1967, and yes, these are all held in United Soviet Socialist Republics, or the Soviet Union itself, but not so much later. Anyway, this is where the International Physics Olympiads were held. Interesting to look at because it's really all over the world, and these papers are they come in a zip file. Oh, I'll let you know what's in them. Oh, it's just a PDF that they've put in a zip file. Yeah, there are the papers and solutions in these questions, so be careful not to surprise them or spoil them for yourself. But anyways, that's all of the content I have for you today. I hope this video was helpful to you if you're looking for resources or just stores and volumes of questions to look at. So until next time, thank you for watching.